Okay, I'm not sure exactly where we lost the battery, so I'm going to come back here to like terms, and I'm going to show you the definition again because I'm not sure that you got this. There are terms that contain the same variable raised to the same power. And that'll make more sense when I give you some examples. So one example would be, let's do 3, 12, -6, and 1/2. Those are all like terms, and here's why they're like terms. They are like terms because they are all constants. They have the same variable, which is none. Okay? They have no variable, so they would be all like terms. All right? So these would all be the same like terms. Just think about it as being like apples and oranges. If I want to be specific, I can only combine apples and apples and oranges and oranges. So I have to, when I'm going to be working on these equations here pretty soon, we're going to be combining these like terms, and you can only combine things that are common, and these are constants. Okay, let me give you another example. 7x, 2x, 0.6x, and x. All of those are terms. We know they're terms that contain the same variable. They all have x as their variable, and they're raised to the same power. They're all x to the first power. Okay, let's look at another one. Let's do 3x squared, -1/2 x squared, and just plain old x squared. These are all terms that contain the same variables. They all have x as their variable. They are raised to the same power. X is raised to the second power. You got to be real careful about this because sometimes you'll have something that looks like this. 3x squared y, and then you'll have 4xy squared. First of all, do these terms have the same variables? X and y, yes. But are they raised to the same power? The x is raised to the second power here, and the y is raised to the second power. So these would not be like terms. Okay, if you have 4xy plus 2x, first of all, look at the whole term, 4xy and 2x. Those are our terms. Maybe I should circle those. That's term number 1, and this is term number 2. If I look at those terms, do they have the same variables? This term has xy, this term has x. They do not have the same variables, so they would not be like terms. We're going to practice this quite a bit. All right, so you should have one piece of pie left, and in that last piece of pie, I would like for you to write down any questions about this vocabulary that you've had while you're watching this video. Maybe something's confused you, maybe I've not been clear about something, or maybe you just have a question about one of them. Maybe it was a review one from 6th grade that you've kind of forgotten, that maybe I went too fast. You write down that question, and then tomorrow we're going to get in groups and talk about them and see if we can answer those questions. So you have questions or comments. Maybe you remember something that I've forgotten that you say, hey, Miss Hardison, this would be really good, a good memory device for one of my, for my classmates. You come up with something, questions or comments that you might have about the terms, how it was presented, something I may have forgotten, something that you just really don't get. Just go ahead and put those down in this last pie slice. And then tomorrow when we get in here, we will take our circle and we'll cut it out. We'll glue it into our notebooks, and we'll have into our interactive notebooks, and we'll have our notes ready. So all we'll have to do is practice then. So I hope you enjoyed this. This is probably going to be something we're going to do more often. So we'll see how it works. See you later.